All right, so class, let's take a look at a few examples of multiplying and dividing powers of 10. All right, so here's the first example. Um, 2 times 10 to the third times 10 times 10 to the fourth. All right, so whenever you multiply numbers that have a power of 10 associated with it, all you're doing is all you want to do is multiply the two outside numbers, and then what you're doing with the exponents is you're just adding them. All right, so let's look at this example. So 2 times 10 is 20. So here's our base 10, and now we're trying to figure out what to do with the exponent. So like I said before, all we're doing is adding them. So 3 plus 4 equals 7. So 20 times 10 to the 7. So now ask yourself, is this in scientific notation? Because that's what I want you to express your answer in scientific notation. Well, for this example, it is not. So 20 is too big. So what we have to do is move our decimal one spot to the left. And so what we're doing is we're making this number smaller because it's 2.0 or just 2. And so we do the opposite with the exponent. We make the number smaller. So we need to make our exponent bigger by however many times we move the decimal. So this would be times 10 to the 8. So just to double check, we made our number smaller. Therefore, we need to make our exponent bigger. We move our decimal to the left. We are adding to our exponent. All right, so let's take a look at this one right here. The next one. All right, so this is 0.02 times 10 to the minus 3 times 4 times 10 to the 4th. All right, so a couple different ways you could have done it. You could easily just multiply the 0.2 times 4 and got 0.08. But what I like to do, I like to work with whole numbers. So my method would be I would convert this number into a whole number by moving my decimal 2 places to the right. And so what am I doing to this number? I'm making it larger by moving the decimal to the right. So what do I need to do with my exponent? My exponent needs to get smaller by however many times that we move the decimal. So this will be, if I rewrite this one, be 2 times 10. I move my decimal 2 places, so I need to make this number smaller by 2. So it'll be minus 5. And so now I can bring my other half down, 4 times 10 to the 4. And so now it's a little bit easier to work with. I'm still doing the same thing I did before, multiplying the two outside numbers. So 2 times 4 would be 8 times 10. And so now we need to add our exponents. So negative 5 plus 4 will give you a negative 1. All right. Well, let's back up. Let's do this from the other way and see if we get the same thing. Erase all that. So if we just decided to multiply the 0.2 times 4, we'll get 0.08 times 10 to the, so we just need to add our exponents. Negative 3 plus 4 would give us what? 1. And so now what you need to ask yourself is this number in scientific notation? It is not, because this number is too small. Scientific notation, it has to be greater than or equal to 1 and less than 10. So this one is definitely less than 1. So we need to do some converting. So we need to move our decimal 1, 2 places to the right. And so we're making this number larger. So therefore we need to make the exponent smaller. So that'll be 8 times 10 to the minus 1. I drew it out on the number lines. And if we started with 1, 2 places to the, move the decimal 2 places. So therefore you got a -1 just like we did before. All right, so let's take a look at some dividing examples that where the number have a power of 10. All right, so dividing numbers that have a power of 10 are the opposite of multiplying. So instead of adding the exponent, you're going to subtract the exponent. And you still perform the same basic calculations with the 2 outside numbers. Instead of multiplying, now you're dividing. So that's straightforward. So 20 divided by 5 will be, so you get to 4 right here, times 10. And so what you're wanting to do is you want to subtract the exponent. So 5 minus 3 will give you 2. And so this number in scientific notation, yes, it is. So this one's done. All right, so let's take a look at the next one. So go ahead and divide the outside numbers. So 36 divided by 3 will give you 12 times 10 to the what? So we need to subtract our exponent. So 8 minus a -2. And if you're familiar with keep it, change it opposite, so you keep this number, change the sign, make the sign opposite. So it's really 8 plus 2, which is 10. So this number should be 12 times 10 to the 10. So now is this number in scientific notation? No, it's too big. So we have to manipulate it a little bit more by moving the decimal to the left 1 spot. And so we're making this number smaller. So therefore we need to make the exponent, that's right, larger. All right, so let's look at the last one. 25.5 times 10 to the 2 divided by 2 times 10 to the minus 4. So this one was a little different, but I thought it'd be interesting to work this one out. So this whole part right here, 25.5 times, divided by 2. I don't expect you to perform that calculation in your head. Just go ahead and pull out your calculator and just go ahead and divide it. So this is 25.5 divided by 2, which equals 12.75 to 12.75. And so now what we want to do is figure out our exponent by subtracting our exponents. So it'll be 2 minus a -4. Keep it, change it opposite. Keep this number, change this sign, make this sign the opposite. So it's really 2 plus 4, which will give you 6. So this number is 12.75 times 10 to the 6. Is this in scientific notation? No, it's not. So you need to make this number smaller by moving the decimal one spot to your left. And so if we make it a number smaller, 1.275, we need to make the exponent bigger by however many times we move the decimal. So we only moved it once, so we want to make the exponent bigger by 1. And so that's it for those examples.